Hello, and welcome to the series of math modeling introductory tutorials. Today, in Lesson 1, we are going to talk about the philosophy of math modeling. Well, math modeling seems to be all about math. However, in order for us to construct better models, it is crucial for us to start by understanding the underlying philosophies of math modeling. So, now, let's get started. Now, let's look at a simple question. What is a model? A model is in fact just a form of simplification instead of all these complicated and fancy things you might think of it to be. What it allows us to do is that it allows us to simplify these complex and real-world phenomena into something that we can describe with mathematical relationships, which is considerably easier. And let's look at an example. So, we can see that through a model we can simplify the inner workings of a dam, which is a really complicated thing, into a considerably simpler system of equations. Now, we need to understand this really important concept in math modeling, and this is best brought out by this quote from statistician George Box. That is, all models are wrong, but some are useful. So, the keywords here are apparently wrong and useful. So, now we are going to explore why the models are wrong and how they can be useful. So, why are all models wrong? Actually, this is because that all models are based on assumptions. An assumption is something that we have to believe to be true when we build a model. Why do we need that? Because assumptions help us simplify the situation to make it possible for us to describe things with mathematical relationships. However, unfortunately, because of the existence of these assumptions, no model can perfectly describe anything. This is why all models are wrong. Now, let's look at a way that makes models useful. First of all, our models should have valid assumptions. This means that assumptions should make sense logically, and it would be best if it is backed by evidence. Also, because we need to keep in mind that the main aim of our model is to imitate the real world and to describe it, our assumptions should not prevent the model from imitating the real world. Let's look at this example. Say we want to model an airplane. However, we assume that gravity is negligible. Would this make this model useful? No, because if we say that gravity is negligible, the plane we modeled, it probably can't even fly in the real world. And this is why we need to have useful and valid assumptions. And now, let's look at another way that makes models useful. That is, models need to be easy to use. Because models come from an applicational setting, and we use it to describe the real world, it should also be easily applied to the real world. Therefore, if we have models that require information that is hard to obtain, then it is probably not a useful model. So, it actually turns out that normally, simpler models are more useful. So, a common misconception about math modeling is that you need complex calculus. In fact, you do not always need it, because if you have simpler methods, why do you even care about complex calculus and things like that? It's just like, if a shovel is enough, why do we need a bulldozer? And that is all I have to say about the philosophy of math modeling. I hope you enjoy it, and thank you for listening.